Hi, Chem team. So far we've talked about orbitals as spaces in electron shells where up to 2 electrons can fit. It turns out not all orbitals look the same. For instance, this first shell's orbital is something called an s orbital, in which the 2 electrons that can fit inside of it move around in a spherical shaped cloud. The second shell, meanwhile, has 4 orbitals. One of these orbitals is an s orbital with a similar spherical shape to the s orbital of the first shell. But its other 3 orbitals are called p orbitals. And while they each can contain up to 2 electrons that can move around, these electrons in p orbitals tend to form propeller shapes. So if we wanted to make a more detailed model of our atom and the orbitals that surround it, we'd end up with something more like this, where the first shell's orbital is an s orbital, and the second shell's 4 orbitals are actually one s orbital and 3 different p orbitals. Now, how would electrons fill into these orbitals? Well, take for instance oxygen, which has 8 protons and 8 neutrons. Those 8 protons will attract 8 electrons. These electrons still fill into the most stable orbital first. So they'll fill into the first shell's orbital before they fill into the second shell's orbital, because the first shell is closer to the positive protons. Then the electrons will fill into the s orbital of the second shell before they fill into the p orbitals. It turns out the s-shaped orbital is a more stable configuration for these electrons to be in than in a p-shaped. But after the second shell's s orbital is filled, the electrons will repel into the second shell p orbitals. And what you'll notice is, like with previous Bohr models that we've drawn, electrons won't share orbitals with other electrons. They'll repel into empty orbitals unless there's no other space available in that subshell. And that's it. At this point, you guys have a couple of practice problems. We'll see you in class tomorrow.